Hi everyone, thanks for joining us. Welcome to today's webcast discussing how you can leverage AWS and Tableau to enhance your analysis. My name is Jay Pradhan, Senior Business Intelligence and Analytics Consultant at Thorogood. I've been working with Tableau for over 5 years now, designing and implementing suites of dashboards for customers across banking and consumer packaged goods industries. I'm joined here by my colleague Liam.
Hi guys, my name is Liam. I'm a BI and analytics consultant working alongside Jay. I have experience working on tools from a range of cloud vendors, including Amazon Web Services, or AWS, which is Amazon's cloud computing services branch. So today I will be demonstrating the AWS architectures that you can use to connect your data to Tableau.
Our agenda for today will start with a brief introduction to AWS and its different components. We will then look at the modern data architectures possible with the combination of Tableau and AWS. We will do a quick demo to give you a feel for the AWS components and then look at how you can analyze your data in AWS with Tableau. I hope you find this session useful, and again, please feel free to submit any questions you may have to the host. Thorogood is an independent BI and analytics services firm specializing in strategy and roadmaps, requirements, design, implementation, training, and support. We are headquartered out of London with offices all over the world. Our clients typically span 4 data-rich verticals: consumer goods, pharmaceutical and health services, banking, and insurance, with experience across the board in various functions of these verticals. In terms of technologies we work with, we are an independent consulting firm, meaning we don't work with one specific technology. We do, however, work and partner with many of the key players across the market in order to provide our clients with the solution that best suits their needs. We started using Tableau around 7 years back in 2013. And have established ourselves as a member of Tableau's Partner Advocacy Board, are a strategic alliance partner, and have many consultants globally with experience in Tableau development, as well as integration with other technologies like AWS, Azure, R, Salesforce, and Snowflake. For those of you who haven't had much prior exposure to Tableau, let's do a short introduction to what this tool provides. Tableau is a business intelligence and analytics platform created for the purpose of helping people see, understand, and make decisions with data. Tableau connects to a wide variety of data sources, which includes a range of on-premise sources, cloud data sources, as well as static data sources such as Excel and CSVs. Let us look at a suite of products offered by Tableau. Tableau has 4 major offerings. The first offering is Tableau Desktop. This is an on-premise tool for users to create dashboards and reports in an agile development environment while supporting self-service analytics of their data. The next is Tableau Server, which is a web-based visual analytics platform enabling collaboration amongst users with mobile reporting. With this tool, you can publish data created by users and allow for an enterprise self-service analysis on the data with reports created on desktop. Tableau Online is considered a software as a service very similar to Tableau Server, but is hosted and maintained by Tableau in the cloud. Lastly, Tableau have recently released Tableau Prep. This new offering is a personal data preparation tool that empowers users with the ability to cleanse, merge, aggregate, essentially prepare data for analysis in Tableau. Other offerings like Tableau Reader, Tableau Viewer, Tableau Public are some of the other offerings. I will now hand over to my colleague Liam to take you through AWS offerings and their configurations.
So, as you can see on this slide, AWS featured as the leader in the Gartner Magic Quadrant for Cloud Infrastructure as a Service in July 2019. Now, this is in terms of both completeness of vision and ability to execute. Now, in 2020, its position in this market is still extremely strong. They are able to provide an effective solution for small and large customers due to their flexibility, scalability, and global reach. Today, AWS currently owns a roughly 48% share of the infrastructure as a service market. And although Microsoft is growing rapidly, it is still far behind with only around 15% share in this market. So let's take a look at some of the tools in the AWS stack. Now, the offerings are grouped into categories of services. So let's look into a few that we will be using today. Under storage, we have the Amazon Simple Storage Service Blob Storage. Under database, we have Amazon Relational Database Service, or RDS, which is a managed database service on the cloud, which we'll be demonstrating later. Redshift underneath it is a cloud-based data warehouse tool, and this allows for massive storage with extremely fast query responses. In analytics, we have Athena. So Athena is a querying tool that allows us to query our data sets in S3 using standard SQL. AWS Glue next to it is an ETL tool that we will also be looking into more later on. Let's take a look at some example architectures that can allow us to connect our data sets to Tableau using AWS. Now, the first architecture we're going to be looking at is Amazon Athena, the querying tool which works directly on our data files in S3 blob storage. So let's walk through the steps in this architecture. So the file is originally stored in a container in our S3 blob storage known as a bucket. We will run an AWS Glue crawler, which will scan the bucket and retrieve the metadata from the file within it, information such as table name, column names, and schema. This metadata is stored within the AWS Glue catalog database. Athena can now query our data directly through the Glue catalog using the metadata to understand the structure of our S3 files. And finally, the outputs of our Athena queries can then be visualized in Tableau by providing your AWS credentials. So let's take a look at some of the benefits and limitations of this architecture. In terms of the benefits, Athena can be used on structured or semi-structured data in various file formats, including CSV, JSON, Parquet, or ORC. You just need to point your Glue crawler to the data and specify the schema. Queries are computed rapidly, even against multiple files simultaneously, and with Athena, the cost structure is that you pay per query you make. And so if this is used in the right context, this can be a benefit. This structure makes it perfect for quick ad hoc analysis. But at the same time, if you're firing regular queries, you could quickly build up your costs. And so it's really important that you consider if your use case is appropriate for using Athena. Another limitation to consider is that it's not able to generate read replicas or automated backups of your data in the same way as RDS or Redshift, which we will be looking at later on. So now I'd like to take you through a short demo to show you how this architecture would work in practice. So here we have our S3 buckets. And the two data sets that we will be using today are the CSV files in these two buckets. Okay, and so one has CPG data, and the other contains credit card data. Now, one important attribute that you have to notice is the region of these buckets. So we define this when we create an S3 bucket, and it's really important that the region matches the other relevant AWS tools in the architecture. So quickly to summarize our goal, we would like to retrieve the metadata for our S3 files in these buckets using a Glue crawler and then query these files using Athena. So if we now navigate to the Glue console, so here's a Glue crawler that I created earlier to pull our metadata. Now I'm going to show you quickly how I did it. The first step is we give the crawler a name. In this case, we have not crawled these files before, and so we select data store as our source type. In our case, our data store is an S3. And so next we specify the path. Now it's important that when we're specifying the path, we choose the level of storage above our files. So in this case, we select the entire bucket. And now to save us a bit of time, we will crawl both of our data sets. We will pull in the CPG bucket as well. Next, AWS prompts us to choose an IAM role. Now this essentially defines all the permissions that this crawler will have. Now earlier we have defined a IAM role that grants Glue full access to all AWS resources. And we can now assign that role to our crawler to allow it to read our S3 bucket. Now in a productionized environment, you might want to be more careful about what permissions you give it. We can choose the frequency that we want our crawler to run, and in this case, we will just select on demand. Finally, we then ask to select the database for our Glue data catalog. Now this is where the metadata will be stored. And so here's one that I created earlier that we will use in this demo. And finally, we would press finish to create our crawler. We can then run our crawler from the console here. And within about 40 seconds, our crawler will have populated our Glue data catalog with the metadata files of the data store specified. We can then navigate to the Athena console, and after hitting refresh, we will see these metadata tables populated on the left-hand side. Now, before we can run queries against these, we have to first set our query result location for Athena. All of our query outputs will be stored as CSVs in this bucket. And in this case, we will use a bucket that I have created called Athena Query Outputs. So once we have saved this, we are now ready to start querying using Athena. We can use standard SQL to write queries against the tables in our database and gain really quick insights about our data. So now I'd like to go over how we can achieve the same goal using the Amazon Relational Database Service, or RDS. So let's go through the steps in this architecture. Our file is stored in our S3 bucket. We then use the Glue data crawler again to retrieve the metadata for our tables. We store this metadata into the Glue data catalog. Then we use a Glue job, the ETL function of Glue, to copy the data from our S3 files into our respective RDS database. The data is stored in our RDS database. And finally, we can query it using RDS, or we can connect it directly to Tableau to be visualized. So now let's take a look at some of the benefits and limitations of this architecture. Now, considering RDS is a database service, this architecture is often better suited for productionized systems with structured reporting. RDS is extremely easy to set up and manage, but it still has customizable options around the type of database engine, compute and storage capacity, memory, and other such features. RDS can generate read replicas, which are replicas of the database used to absorb some of the traffic and improve performance. Automated database backups can be retrieved and restored for up to 30 days, providing additional durability. And finally, you pay for your RDS on a monthly basis, depending on the amount of storage, memory, and compute capacity that you've provisioned. And so the data can be queried at no additional cost. However, by the same token, with RDS you will pay for the capacity you provision, whether you are using it or not. And so if your data is infrequently queried or accessed, it may not be a cost-effective option. Also, unlike Athena, RDS can only handle structured data. Finally, there are limits on storage capacity and the number of databases per RDS instance. If these are restrictive, you may want to consider using Redshift, which we will cover later on. So now let's go through a quick demo of how this architecture would look in practice. So we have created an RDS database instance here, and we can view some of the attributes, such as the database engine, in this case a SQL server, and the database instance class, which gives us our processing power and memory. One important thing to notice is that the region, EU West 2A, is the same as that of our S3 bucket, and this is required for our Glue job to work. So, having already crawled the metadata for our CPG dataset earlier, as we can see here, we are now going to define a Glue job which will copy this data from S3 into our RDS database. So we navigate to Jobs and select Add Job. So we define the name of the job, in this case, Glue ETL test. We grant it full access. We provide it the full IAM role access so they can use our RDS database and our S3 bucket. Now the rest of the settings can be left as they are, and we will see what this setting here, the proposed script from AWS Glue, does later on. So we hit Next. For our data source, we will choose our CPG dataset from our Glue data catalog. Now in this case, we will choose Change Schema, so we can just define our schema and map this straight to our target dataset. Finally, we select a table in our target. We would like to create one in this case, as we have not created one yet. And so we will choose a connection to our database instance that I've created earlier, and we simply specify the name of the database within that database instance. Here we can define the column mappings and the schema for our target table. And once we are happy with this, we can then move on to the next panel. So here is the script editor. Now Glue has generated an automated script that will be written in Python, and this script will copy our data from our source to our destination. So now that we have defined our jobs, we can hit refresh. Essentially, once this job is run, it will then copy our data from our S3 file and push it into our RDS. So finally, I'd like to take a look at Redshift. Now this is the data warehouse tool that we discussed earlier. Now the architecture is the same as that of RDS, where we copy the data from our S3 bucket into our Redshift data warehouse using Glue. This can then be visualized in Tableau. One of the main benefits of using Redshift in this architecture is that Redshift is capable of easily handling huge datasets with much higher limits on storage capacity and the number of DBs per instance. The typical setup will provide around a petabyte of storage, and this can be increased even further by adding more nodes. Now, regardless of data size, it still provides extremely fast querying abilities on this data through massive parallel processing architecture. Finally, it offers the ability, in the same way as Athena, to query your files directly in S3 using the Redshift Spectrum tool. And it offers the same data replication and backup capabilities as RDS. Now, for all of this functionality, Redshift can be more expensive. And so if these additional capabilities are not necessary, it may not be a cost-effective option. Also, Redshift is currently only available in one availability zone and is not eligible for multi-AZ deployment in the same way as RDS. As a result, if this availability zone were to go down, you will be unable to access your data. So it's important to consider the criticality of your data. Can you afford for your analytics to be down for a few hours? If not, then perhaps Redshift is not a feasible option. So I hope that's given you a good high-level overview of some of the AWS tool stack and some of the simple architectures that will allow you to connect your data to Tableau through AWS. So now I'm going to pass over to Jay, who is going to take you through the Tableau side of these connections.
Building on top of what we saw with Athena and how you could use this tool to query an S3 bucket, let's now look at some of the prerequisites that you would need to have in place before you can analyze this data in Tableau. You need credentials to your AWS console. Liam showed us today how you can create an S3 bucket and load data into it, and then subsequently use a crawler to move this data into the DB. This is a step that you would need to do ahead of using the setup. Once you've got your Athena source set up, you will need to download a Java driver and a JDBC driver. The Tableau tool should guide you through this process. After this, you're ready to start playing around with your data from Athena. Once you have the prerequisites in place, Tableau is ready to use Athena connector to leverage your data in your S3 buckets for analysis. For the purpose of this demo, I've already created a connector to one of the S3 buckets Liam showcased earlier. It is easy to set it up. You can navigate to the data tab on top of your screen and click on New Data Source. This will open up a screen where you can enter server and S3 bucket details. I've also had to input the access key ID along with the secret access key, which is something that will have to be shared by the AWS portal admin. Once I've established my connections, you can see that I have the option to either use a live or an extract connection. If a live connection is used, each time the data is refreshed in a visual, it will run a query against Athena. This could quickly build your costs if you're not careful, but it's fine for ad hoc analysis. If an extract data is taken in Tableau, then the data cache is stored internally in the Tableau Hyper engine. In this case, the only time the query will be run against Athena will be when your data is refreshed. If your data is not refreshed regularly, that is an effective solution. Let's look at what sort of analysis is now possible within Tableau. Having highlighted the power of Athena to perform ad hoc analysis, connecting Tableau to Athena makes self-service reporting a lot easier. You can connect any column in the data source, drag that in to create quick visualizations to answer business questions. Let us look at how we can create a tree map to understand the split of the amount of spend by each type of card. So I can drag my sum of amounts on different selections and then my card type, and this easily creates a tree map. I've also plotted a trend chart for the amount of spend per year by each type of card. I can use the forecast feature on here, which uses inbuilt ML modeling techniques to forecast spend for this chart based on your historic data. This is very easy to do. All you need to do is right click on the screen and navigate to forecast and do show forecast. You can click here to see how the forecast is created as well. I find this feature quite interesting as it showcases how Tableau is looking to make analytics capabilities available at your fingertips. You can see all of the details of the kind of considerations that went into generating this forecast to help you explain some of the values that you can see on your screen. Hopefully you got a flavor of the possibilities of what you can achieve by pairing Athena and Tableau. In this demo, we will now look at how Tableau can connect to an RDS instance that Liam had created earlier. I can then share some dashboards we were able to build using a live connection to the database via RDS. The process for connecting to the RDS connector is pretty much the same as it is for Athena. You need to input the details of your DB you're looking to connect to in this window. So for now, I've already created a connector. So let me just show you the connector window that comes up. Because the RDS database that was created was a Microsoft SQL Server instance, we connect to that SQL Server instance and mention the details of the AWS server that we are connecting to. We then mention the database name along with the username and password details and sign in. This is a pretty standard way of connecting to a DB. Once you've established connections, you can then proceed to building a dashboard that can help you answer questions with your dataset in RDS. One of the considerations I would like to mention before we get into the details of the dashboard is that it is unable to support semi-structured data. So please ensure that your data is structured before you can start using that in Tableau. As you can see here, I've created a brand dashboard. There are multiple visualizations that have been plugged into this dashboard. I've created a sell-in and sell-out calculation on this dashboard and plotted that in a 3-step chart and use that to create a dashboard. So this dashboard is made up of multiple visualizations. I have my high-level numbers of gross sales value, net invoice value, and total supply chain costs, which are my headline numbers. And I've brought all of this together by connecting to my RDS data source. So let's quickly summarize what we saw with RDS today. Considering this is a relational database, it is set up for regular frequency, low volume data. It has the capability to create read replicas, which allows your main DB to always be available for accepting new data and makes data refreshes efficient. It is easy to scale both performance as well as storage capacity. This gives you the flexibility while reporting and allows you to explore multiple avenues of improving reporting performance. That's all we have time to cover today, although there's plenty more to explore with respect to this topic. We also have a variety of pre-recorded content available on demand on our website at thorogood.com/perspectives. Thank you for joining us today. Again, please don't hesitate to reach out to us with any questions. Thank you and have a great day.